So under matrix algebra, we have discussed how to find the determinant, the properties of determinant, and how to find the inverse of a matrix. So then we are going to solve a linear system using the matrix method. So under solving linear systems, we are going to discuss three methods of solving a linear system under matrix algebra. The first method is using the inverse matrix method. That means we are using the inverse of a matrix to solve the system. So first we will consider a system of two equations with two unknowns. The two unknowns are x and y. We have two equations. That means we can find a unique answer for x and y both. So these are the two equations. Minus 3x plus 4y equals 5. 2x minus y equals minus 10. To solve this system using the inverse matrix method, first we have to put these two equations into matrix form. So when you are forming the matrices, we have to form a matrix for the coefficients, that is called the matrix A. So in matrix A, we put the coefficients of x and y. So when we are constructing this matrix, the matrix of coefficients, you have to make sure that a column represents the coefficients belonging to one variable only. So here if we take the first column of this matrix A, the first column represents the coefficients of x, minus 3 and 2. And the second column represents the coefficients of y, 4 and minus 1. And then the next matrix is the matrix of the unknown variables. It's a column matrix with two elements. The two elements are x and y. And then the matrix B, which represents the right-hand side values of the equations. So the right-hand side values are 5 and minus 10. And then we have to find these two values. That means we have to find this matrix, this column matrix, this 2 by 1 column matrix. So here's how we find these matrix X. So after representing these two equations in matrix form, we can write down it as AX equals B. So now these A, X and B are all matrices. Then if we multiply both sides, the left-hand side and the right-hand side with the inverse matrix of A inverse AX equals A inverse B. So here, in right-hand side, you can't write it as B into A inverse because it does not agree with the matrix dimensions. B is a 2 by 1 matrix. And A is a 2 by 2 matrix. So if you write down B into A inverse, that means you are going to multiply a 2 by 1 matrix with a 2 by 2 matrix, which is not possible. So it should be A inverse into B, right hand side. So this is a 2 by 2 matrix multiplied by 2 by 1. The resulting matrix is also 2 by 1. So in left hand side, if we come back to left hand side, when we multiply a matrix by its inverse matrix, it is always equal to the identity matrix, regardless of the dimension of this matrix A, right? For any square matrix, if you multiply it by its inverse, then it is always equal to the identity matrix. So here we get a 2 by 2 identity matrix. Identity matrix into X equals A inverse B, and when we multiply a matrix by the identity matrix, again it gives you the same matrix. So it is like you multiply a scalar. If you multiply a scalar by 1, then again it is equal to the same scalar. So this is like that in matrices, when you multiply a matrix by the identity matrix, it is always equal to the same matrix. So IX means identity matrix multiplied by this matrix X is equal to X. So x is equal to A inverse B. So this is how you find this matrix X, or the column matrix of the unknown variables. That is, you have to find the inverse of A and multiply it by B. So these are the two equations, and then we have to find the inverse of matrix A. So this is how you find the inverse of a 2 by 2 matrix. 1 over determinant of A. Determinant of A is 3 minus 8. Right? 3 minus 8 is minus 1 into minus 3 is 3. Minus the cross product of these two elements, 2 into 4 is 8. And then this is how you find the inverse of a 2 by 2 matrix. And then the inverse is equal to this matrix. And then we have to multiply this inverse of A with B. This is a 2 by 2 matrix and B is a 2 by 1 matrix. So the multiplication is possible. And then here you have to perform the matrix multiplication. So after multiplying these two matrices, X is equal to this column matrix minus 7 and minus 4. So this is equal to these two elements. So that means we can find the answers of X and Y. X is equal to minus 7. We take the corresponding elements of the matrices. The first element is X. The second element here is equal to Y. So X is minus 7 and Y is minus 4. So the solution of the system is minus 7 and minus 4. So you can do these two questions using this inverse matrix method. In part A, it's a system of two equations and two unknowns. In part B, there are three variables and three equations. That means you can find unique answers for X, Y, and Z using the inverse matrix method. So in part B, you have to find the inverse of a 3 by 3 matrix and then multiply it by the right hand side values and find the values of these unknown variables. So here I have taken another example of a 3 by 3 system. So here we have three unknown variables and three equations. First we have to construct the coefficient matrix. So the first column represents the coefficients of X, 2, 1 and 3. The second column represents the coefficients of Y, 3, minus 1 and minus 2. The third column represents the coefficients of Z, minus 1, 2 and 1. And then we construct the column matrix of unknown variables. So now X is a 3 by 1 matrix. The unknown variables are X, Y and Z. And then construct the column matrix with the right hand side value. So B is equal to this column matrix 9, minus 3 and minus 2. So the system in matrix form is AX equals B, and then we can find the matrix X by multiplying the inverse of A with B. So this is how you find the inverse of the 3 by 3 matrix. First we find the determinant of A. So we have already discussed how to find the determinant of a 3 by 3 matrix, so I'm not going to explain this one again. The determinant of this 3 by 3 matrix is equal to 20. And then we have to find the minor of A. Right? Minor of A means you have to find the minor of each of these 9 elements here. Minor of 2 is you eliminate the first row and the first column, the corresponding row and the corresponding column, and then take the determinant of the remaining 2 by 2 matrix. The determinant of this 2 by 2 matrix is equal to 3. So likewise, you can find the minor of 3 and write it in the place of 3. Find the minor of minus 1 and write it in the place of minus 1. So this is called the minor of A. And then the cofactor matrix means incorporating the place sign into the matrix of minus. The matrix of minus, if we incorporate the place sign, we know the place sign is plus here and then minus, again plus. So if we have positive signs, there's no change in the cofactor matrix. This is 3. Since here we have a negative sign, minus 5 becomes plus 5, and here this is 1. And when you come to the second row, the sign is minus, plus, and minus. So this is minus 1, 5, and 13. Third row is again plus, minus, plus. So this is 5, minus 5, and minus 5. This is called the cofactor of A, or the cofactor matrix. And then the adjacent matrix, then the adjoint of A is, adjoint means we have to take the transpose of the cofactor matrix. Transpose of the cofactor matrix means we write down the rows of this cofactor matrix as the columns of the adjoint matrix. So the first row here will be the first column, second row here will be the second column, third row here will be the third column. So this is called the adjoint of A. To find the inverse of A, inverse is given by adjoint matrix divided by the determinant of A. That means if we divide this matrix by the determinant of A, it is equal to the inverse matrix. The determinant is 20. So this matrix divided by 20 means we can write it as 1 over 20 times the adjoint matrix. So this is the inverse of A. Then to find this column matrix X, X is equal to A inverse into B. So we have to take the inverse matrix and multiply it by the right hand side values or the matrix B. So if we multiply these two matrices, we get a column matrix, 3 by 1 column matrix. So this is the resulting matrix after the multiplication. So that means we can find these values of x, y, and z. The first value here is equal to x. So x is equal to 1. The second value here is equal to y. So y is equal to 2. And the third value here is equal to minus 1. So z is equal to minus 1. So I hope you have got this method using the inverse matrix method to solve the system.